So as you're writing these notes down, I'm just going to talk about them. And I'm going to go, like I said, as slow as I can while at the same time keeping in mind the time for this class. So at the beginning of the year, we talked about absolute values and the definition of absolute value being the distance away from zero. So for example, we understand, or we should understand, that if I have the absolute value of a negative 10 or the absolute value of a positive 10, in both cases, the answer to that is going to be 10 because you're 10 units away from 0. So, you would not be surprised to know that if I rewrote this as the absolute value of 10 minus 0, then I'm still going to get the same answer of 10. Now, why did I write it like that? Well, because when we start seeing more complicated equations, the answers to those absolute value equations are really interpretations of this. They're saying that that answer, whatever we get, we know that the absolute value of 10 is 10. That answer is 10 units away from 0. Does that make sense? 10 units away from 0. This may change. It may not be a 0, and we'll look at cases in which it is not a 0. So, what should you write down? I would make sure that you have 1 through 4 written down. You don't necessarily have to concern yourself with this because it's a little bit confusing. Once I explain it, hopefully it won't be as confusing, but do give it a chance and give us a chance to go through examples before you give up on it. So, number 1 is just a basic rule. If I have an absolute value of a number, it is always going to be positive. Number 2 is saying that if I have the absolute value of a negative number, the rule still applies. I'm going to get a positive value. It's going to be the same thing as taking the absolute value of that positive number. Number 3 is saying that you can always break down an absolute value into the product of two numbers, two absolute values, in fact. So, you could, for example, break down the absolute value of 12 into the absolute value of 3 times the absolute value of 4. And you'd still get the absolute value of 12, which is 12. Number 4 is saying the same is true for division. You can break down your division into two absolute values divided by each other, but you cannot have 0 in the denominator because then we'd have undefined. Does everybody understand 1 through 4? Okay. The next part is where it gets really confusing. So please do stop me at the end if it does not make sense. So, let's say you're given an equation to solve. To solve any absolute value equation, you're going to follow a specific number of steps. The very first step you're going to ask yourself is this: is my absolute value equation set equal to a negative number? If the answer to that is yes, and you've done everything to get the absolute value by itself, then you have no solution. So for example, if I have the absolute value of 2x plus 1 equals negative 3, that would have no solution because absolute values cannot be equal to negative numbers because absolute values are always positive distances. Does that make sense? Great. Now, you're not always going to get a situation like that. You may get a situation in which it is possible to solve your absolute value equation. Let's say you have this. Well, obviously in this case with that absolute value, I have that set equal to a positive 3. In this case, I proceed to the next step. What is the next step? The next step is to say, what is my definition of absolute value? My definition of absolute value is that it must always equal a positive. It's okay if the inside is negative. Why? Yes.
Will it come out positive?
Because it will always come out positive. That's exactly right. So when you solve these, when you go past the first step and you say it's set equal to a positive value, you're going to solve it in the following way. You're going to break it up into two equations and get rid of the absolute value sign. Set it equal to positive 3. So in this case, you'll have 2x plus 1 equals positive 3, because it's all right if we get a positive 3 on the inside, because the absolute value of a positive 3 is a positive 3. And you're also going to set it equal to a negative 3, and that's okay, because if that's equal to a negative 3, well, the absolute value of a negative 3 is also a positive 3. Does everybody understand that? That's great, because my last period did not, and I had to explain it 5 times. Are you sure? Okay. Just want to make sure. So for this next one, first step is to say, is it equal to a negative? The answer is no. So I proceed to step 2. So I break it down into 2 equations. What's one of them? X minus 4 equals 6. So if I get a positive 6 on the inside, that's good. So I'm going to solve for x and solve for x. And I get x equals 10. And you always want to check with absolute value, and I'll tell you why in a different slide. But 10 minus 4 is 6, and the absolute value of 6 is 6, so that works. Now, I have another equation. What's the other equation? X minus 4 equals what? Negative 6. Because if I get a negative on the inside and take the absolute value, that's okay, because I'll still get 6. So I'm going to add 4 and add 4. X equals negative 2. I'm going to double check to see that this is in fact a solution. So negative 2 minus 4 is negative 6, and the absolute value of negative 6 is positive 6. So that works. Do you have questions? Now we're going to look at the graph. So you're going to be asked to graph the solution on a number line, and I did it for you here in just a second. So remember how in the beginning I said if you had 10 minus 0, the absolute value of that equals 10. What you're really saying is that 10 is 10 units from 0, right? So let's look at it here. This is what these answers are saying. This positive 10 is saying, okay, positive 10 is 6 units from positive 4. It's always the opposite sign on the inside. You want to remember that for future chapters, always the opposite sign. And is 10 in fact 6 units from 4? Yeah, it is. And then the same is true for negative 2. Is negative 2 6 units from positive 4? It is. So that's what those solutions mean on a number line. Does that make sense? Okay. What do you think the solution for B is? No solution. Why is it no solution? Because it's a negative, and absolute values are distances from numbers. Okay, so that's no solution. On the first one, I asked myself the same first question. Is it set equal to a negative? The answer is no. So if it's not set equal to a negative, I have to split it up into 2 equations. When I split it up, that allows me to get rid of the absolute value bars. Oh, it's on freeze. I'm sorry. So you get that. Did everyone get that for the first one? Okay, the next one is set equal to, yes. Yes, you had to. You had to. Because the absolute value of a negative 10 is also 10. That's why we split it up into 2, because you can have 2 answers. It's not like last time when we solved equations and you got one solution for x or IMS or no solution. With absolute value, you have the possibility of having 2 solutions, 1 solutions, or no solutions. Okay, so for the next one, it's set equal to a positive, so what's my next step? 2 equations. What's one of them? X minus 1 equals 4. What's the other one? Yes. And then I solve it. x equals 5, x equals -3. Do those both work? 5 minus 1 is 4. That works. -3 minus 1 is -4, and the absolute value of -4 is still 4. So that works as well. What's the answer to the next one? No solution, because it's set equal to a negative. Are we good? Okay, gets harder. So I'm going to add 10 to both sides. Because initially you'd look at this and say, oh, I can't solve it because it's set equal to a negative. But when you add 10, what's it set equal to now? A 6. Well, now I can solve this by breaking it up. Subtract 9 and subtract 9. 3x equals -3. Divide by 3 on both sides. X equals -1. And you can plug it back into here. You don't have to plug it back into the original one. So -1 times 3 is -3 plus 9 is in fact 6. So that works. And then I'm going to go to the next one. -9 minus 9. 3x equals -15. X equals -5. Plug that back in. When you plug that back in, you get 3 times -5 plus 9. And that equals the absolute value of -6, which is still 6. Does this all make sense? The other thing that people do that's wrong is they'll look at something like this and they'll start distributing. Resist the urge to distribute. What you want to do instead is just divide. Okay, so since I have a multiplication here, I'm allowed to do that because of inverse operations. And a lot of the times with your distribution problems, if you have this, you don't have to distribute. You can just multiply both sides by 2 to save the distribution step. And that's exactly what we're doing with absolute value equations. We're not distributing, but instead we're just getting rid of whatever's in front right away by doing that inverse operation. Does that make sense? And then we can solve it as normal. Split it up into 2. Any questions? Okay. Getting any of this on the recording. There we go. So this is number 6 if you're watching. Got rid of the 3, or the -3 by adding 3 on both sides. Then got rid of the -2 by dividing by -2 on both sides, as you can see with the steps here. Then I'm just solving this, adding 1 and adding 1. So I end up with 5x equals 5, divide by 5, divide by 5, x equals 1. And then I add 1 here and add 1 here. 5x equals -3, divide by 5 and divide by 5. X equals -3/5, which is the same thing as -0.6. Questions? Yes?
So we write both solutions no matter, like, even if it's not the same?
So you write both solutions if, when you check it, they both work. So if you can plug it into this one because this is simpler because you got rid of everything around it. So when you plug in -0.6 times 5 and then you subtract 1 and take the absolute value, you should get 4. And then when you do the same thing with 1, 5 times 1 is 5, 5 minus 1 is 4. That also works. So they are both accepted as solutions. but they may not always have two solutions. And we're going to look at that in the next slide. But you do want to write both of them. They are both true. Sometimes it doesn't have two solutions. It may have one, it may have none. And all you need to know is this part because this is asked on a quiz. What is an extraneous solution? Thinking about this so I can get it on the recording, but if you're watching this, just as a reminder, with absolute values, when we solve it and we get two solutions, one of them may not work. And that's okay. That's called an extraneous solution. It means we solve it, we check it, and when we check it, it doesn't check out, so it's extraneous. Okay, so, and I think of extraneous like strange. Extraneous, strange, I don't know, kind of, sort of, maybe. Something that doesn't work. It's on your quiz, by the way. Toss it. Thank you. All right, so you don't have to write all this down. Let's just talk about it. You will have a problem like this on your exam. And don't freak out because it has a variable. You're going to follow the same steps. You're going to say, I have an absolute value. I've gotten rid of everything around that absolute value, and it's set equal to a positive, so I'm going to solve it in the same way. I'm going to set up two equations. One is going to be equal to positive 4x. One is going to be equal to negative 4x. Solve it as such. When you solve it, you have two solutions. One of them doesn't work. X equals negative 2 doesn't work. Why does it not work? When I check it, what would you do if I said check this? What would be your steps?
You would plug it in.
Plug it in where?
On the X.
I would plug it in here, and I would plug it in here. What happens here when I plug it in negative 2? It becomes a negative. And can I have an absolute value equal to a negative? No, that's just wrong. Just wrong. Okay, does that make sense? Every year I have a problem like this and I get one or two students that just skip it. So don't look at this with the variable and be like, well, I'm done, and move on, okay? It's still the same steps. Check your solutions to